Hey guys, welcome to this week's video. So we're continuing our lessons on Pythagorean theorem. Today we're going to be talking about the converse of the Pythagorean theorem, which just means the opposite. So last week we were saying, okay, here's a right triangle. We have two sides, find the third side. What we're going to be looking at this week is basically trying to decide, is it a right triangle? So last week we were given the information like it is a right triangle. This week we need to figure out whether or not it's a right triangle. So the way we do that is we're going to be given three side lengths of some triangle. So we're given three side lengths and we need to figure out if a squared plus b squared equals c squared. If it does, then it's a right triangle. If not, then it's not a right triangle. And that's basically the only question we're answering this week is it a right triangle? So we have three examples we're gonna go through. That is all our notes, so hopefully some quick notes today. So example one is we're given side lengths 28, 45, and 53. And we're asked, could those be the side lengths of a right triangle? And we're not quite sure yet, so our steps are luckily the same as they were last week. We're going to first label A, B, C. 2, we are going to evaluate that equation, A squared plus B squared equals C squared. And then 3, we're going to solve. All right, so our first step is to label. Again, we're gonna be labeling A, B, and C. This time without a triangle, without a triangle, the way we figure out A, B, and C is we kind of take C off the table. We say, okay, C is our hypotenuse. It's always gonna be the longest side. So I look for the largest or the biggest number. 53 is the largest. Boom, that's my C. The other two are the legs, A and B, and those can go in any order. I'm just gonna keep things fairly simple and put it in A, B, C order. 90% of the time, they're gonna be given to you in this order where C is gonna be the last one. We'll look at an example today where that is not the case. It's always good to just double check that they are in order and that the last one is your biggest one, which is C. That's the most important thing. A and B can be either of the two smaller ones. So we've labeled our A, our B, and our C. And then we want to evaluate. So we're going to use that same Pythagorean theorem. We're going to say basically, does 28 squared plus 45 squared, does that equal, and I'm putting a little question mark above my equal sign because I'm not sure if it's a true statement or not, does that equal 53 squared? And then I simply just plug in that information into my calculator to solve it. Step by step, this looks like this. I say, okay, 28 squared is 28 times 28. That gets me 784 on my calculator. Nothing I would expect you to know off the top of your head. 45 squared, if I plug that into my calculator, I get 2025. Say, is that equal to 53 squared? Well, 53 squared is 2,809. If I add these two up, I do get 2,809. That does equal 2,809. So since I have the same number here, they are equal. So my answer would be yes, this is a right triangle. The Pythagorean theorem only works for right triangles. So if A squared plus B squared does equal C squared, which it does in this case, then that triangle has to be a right triangle. It can't be anything else. And it's kind of simple as that, guys. You do not need to break these down as much as I did. You can plug that whole equation into your calculator, get an answer, write that answer down, 2,809, and then take 53 squared in your calculator and get that and automatically go from there. You don't need that middle step. I was just simply showing you that that is another way to do it. The nice thing with this is our steps are exactly the same from last week. So let's take a look at another example. You have room on your paper, go ahead and just keep that. I'm just gonna kind of strategically do some erasing. I'm gonna keep my steps, keep my question of, is this a right triangle? So my example number 2 says, okay, I have side lengths 17, 22, and 29. So my step number 1 is to label as always. So I'm labeling A, B, and C. C being the hypotenuse, C also being the longest side, so which is my largest number. That would be 29. So there's my C, here's my A, here's my B. So I've labeled. Now I evaluate. I plug it into the A squared plus B squared equals C squared model. I solve it. I'm gonna put this right into my calculator, 17 squared plus 22 squared. The calculator does the work for me, and I get 773. I say, oops, is that equal to 29 squared? So I plug in 29 squared into my calculator. I get 841. 773 does not equal 841, so those are not equal. So no, this is not a right triangle. It'll still be a triangle, but it won't be a right triangle. Okay? And our justification, our explanation of that is our work right here. All right? So let's take a look at our last example here. And this is it for the notes this week, so hopefully nice and short. So example 3, we are given side lengths of 15, 39, and 36. So my step 1 is to label those side lengths, labeling them A, B, and C. C is gonna be my hypotenuse. It's gonna be my longest side, my largest number. So this is just an example where it's not necessarily written in order. The numbers aren't written in order. So 39 is the largest of those 3, so that's my C. I then label my other ones. Just double checking that when I evaluate this, I do in fact get A squared plus my B of 36 squared equals my C of 39 squared. Sorry if you can hear Max in the background. I plug 15 squared plus 36 squared into my calculator. My calculator gets me 1,521. If you want to do that step by step, you most certainly can. Get 15 squared and then 36 squared and then add them together. You'll get the same answer. I then put 39 squared into my calculator. I get 1,521. So that is equal. So yes, this is a right triangle. And that is done. My justification for that is my work that I'm showing right there. So that is it for the notes for this week. It for Converse of the Pythagorean Theorem. You guys have an IXL and a Google form with those sorts of questions on there. Have a great week.